We're going to kind of make a graph to represent this graph, and we're supposed to be using the midpoint formula, and we want three rectangles. Well, if you notice here, if I go every space, 1, 2, 3, 4, 5, 6, that'd be 6 rectangles. I want half that. So we got some graph, and I really don't care what it looks like. So I'm just going to say, hey, this graph's going like that. Doesn't matter. So my rectangles, we're doing a midpoint rectangle, but my rectangles are going to come from the second one, but I'm going to do them from the midpoint. So that is going to be my height at 5. So my rectangles are going to look like, there's the first one right there. That's going to be one rectangle, but I want this height. This height is going to be 5.6, which means out here it's 5.6, and this base is 0 to 10, which is 10. Again, the second rectangle is going to come from this midpoint. And this height at 15, I'm going to circle them. There's a midpoint. That's going to be a midpoint. That's going to be a midpoint. Those are the heights I need. So this height is 4 right here, which makes this height 4, and this base is also 10, because 10 to 20 is 10. And then I've got another rectangle out here from this midpoint. Let's see, my graph is totally wrong because the midpoints are actually look like they're going down, right? So I got them going up. But even though my picture's wrong, it does not matter if I got the right numbers in there. That's still 10. And now my height is just 2.7. So the integral of 0 to 30 of r prime t dt is going to be approximately, the midpoint was, height was 5.6 times the base of 10, plus the midpoint height was 4 times the base of 10, plus the midpoint height was 2.7 times the base of 10, and that's going to be my answer. Now, you could, does it say, using correct units? Do you see that deal? Using correct units, so it's kind of a big deal here. So I guess I'm going to go ahead and simplify this. So this would be 56 plus 40 plus 27, which would be 96, 100 and, let's see, 6 and 7 is 13, carry a 1, 123. Now, T, it said that T was minutes, so this is minutes. And it said the balloon expands there high. The radius of the balloon is in centimeters. Now that's the radius, right? Radius, so the derivative of the radius, because time is in minutes, would be centimeters per minute, because it's a rate. So if I take minutes times centimeters per minute, that would be, anybody? Centimeters. So we would write this answer using correct units, explain the meaning of this context. Okay, so I actually screwed up. Okay, so here's what we would do. We would say the radius of the balloon is approximately 123 centimeters from t equals 0 to t equals 30 minutes. That's what you would put. No, you would just say the radius, the balloon's radius is approximately 123 centimeters from t equals 0 to t equals 30 minutes. That's all you put. Because R, it says up here that R is the radius of the balloon. And we're finding R because we did the integral of R prime, which is R. Okay. All right, we're going to go and do another problem somebody wanted was 4. Oh, I hope it's on there. Oh, it's on there just perfectly. All right, now this says that the derivative of capital F of x equals f of x. F of 2 is equal to 3. F of 1 is -1. F of 0 is 2. Then the integral from 0 to 1 of f of x minus the integral of 1 to 2 of f of x dx is equals which one of these? All right, so this is kind of a toughie. F prime of x equals f of x. So let's do this integral. So the integral from 0 to 1 of f of x dx. Okay? So this right here is the same as capital F prime of x, right? Is everybody okay with that? So if I do the integral of f of x, or even maybe even better, if I put in here, maybe I should do this. Let's do it this way. Come on. I'm going to go ahead and write this other one down. The integral of 1 to 2 of f of x dx, that is still equal to, because of this statement right here, that's the same as the integral from 0 to 1 of capital F of x dx minus the integral of 1 to 2 of capital F of x dx. Oh, F prime. I should put a prime in here, my bad. Right? Does everybody see these are equal? Now, what's the integral of F, capital F prime? Anybody know? It's capital F of x. So this is capital F of x is going to equal, I'm sorry, I should just put, this part is going to equal capital F of the top number minus capital F of the bottom number, and then it's minus, same thing over here, this would be capital F of the top number minus capital F of the bottom number. So all I'm doing is using the fundamental theorem of calculus there. Do you see it? So f of 1, well, right here it says f of 1 is -1. So this is going to be -1 minus, it does, f of 0 is 2. I'm plugging that in for f of 0. Minus f of 2 is 3. Minus capital F of 1 is -1. See what we've done there? So now I've got -1 minus 2, that's -3 minus, and this would be 3 plus 1 is 4. So -3 minus 4 would be -7. Okay, there's another thing I've been asked to do, and it's from the notes. It's from the notes of 6-7 and 6-8. And I've been asked to do these two problems, E and F, from the notes of 6-7 and 6-8 notes, which is integral rules. So we're supposed to do, I'm going to use that fundamental theorem of calculus I just had. So we're supposed to know that if you do the integral of e to the x, it is also e to the x. And then you take these intervals and you move them over here. Because what you do is you plug in those intervals into the top. So it's the top plugged in minus the bottom plugged in. So we're supposed to know that e and natural log cancel out, so this is 5, and anything to the 0 power is 1, so this whole thing would equal 4. Is that too fast? Now we also want to do the integral of this one. There is no such thing as a quotient rule, okay? There is no quotient rule in this, so we need to get this not to be a quotient. So there's what I would do if I were doing this is I would take that 3 as a coefficient and move it out front and do the integral of 1 over x 1 to the e squared. Now we do have an integral from 1 over x. It's the only quotient one we have an integral for, and I don't know if you guys have watched your notes yet, but it is the natural log of x. And again, you take your intervals and you stick them out here. I don't know if you watch your video. So we take 3 stays out front. We plug in the first one minus plugging in the bottom one. So you are supposed to know from back in your old days of other classes is that natural log and e cancel each other out. So that's 2. And the natural log of 1 is 0. So this whole thing would be 6. Now those are from your notes from 6-7, 6-8. I don't know if I didn't do that problem, maybe, because I've been trying to get a lot of stuff done, but that's how you do that problem. Does anybody else have anything they want to see?